Hi students, this is AJ sir. Let's study 10th standard ICSE Math, Chapter 9C, Multiplication of Matrices Vector. Exercise 9C, cancel SE number 17. We shall study how to multiply two matrices. 1.2, matrix into matrix. First, we need to determine the orders of the two matrices. Here, the order is 1 by 2, that is 1 row and 2 columns. And here, the order is 2 by 2, that is 2 rows and 2 columns. To check the compatibility of matrices for multiplication, look at the number of columns of the first matrix and the number of rows of the second matrix in the multiplication. Only if they are the same can we multiply them. If they aren't same, we can't multiply them. Not only that, the answer, that is the single matrix, will have the order 1 by 2, that is the leftover numbers. So let's take an example here. These two matrices are compatible. We'll get a single answer, a single matrix, and that should have 1 row and 2 columns, as you can see in this answer. So there are 2 elements, but how do we multiply it? Remember, it's always row into column. So here, the first element will be the first row of the first matrix multiplied by the first column of the second matrix. And then this will be the first row of the first matrix into second column of the second matrix. Now this is a very new kind of math that we are going to study, which may seem very weird initially. So you will need to go slow in this exercise to master this new art of multiplication. You'll have to think about the rules again and again and keep checking your answers rather than just copying. This is the only way you will find this exercise as easy as the previous ones. So 1 into minus 2 is minus 2. We write that. Plus minus 2 into minus 1 is 2. So plus 2. So that's how we get our first element. We have multiplied the first row with the first column. And whatever answers we got, we just have to add them. And minus 2 plus 2 comes out to be 0. Next, again first row into the second column. Remember, this is also belonging to the first row and it is in the second column. So that's a hint. So 1 into 3 is 3 and minus 2 into 4 is minus 8. So 3 minus 8 is minus 5. Now make sure you leave a lot of space between different elements. You should not be confused about whether these are two different elements or it is a single element. There are a lot of silly mistakes which you will make initially, but that's fine. You have to learn from these errors. And you have to train your brain to visualize matrices in a very different method compared to other math. But certain hints which I will give you will really help you to avoid silly mistakes. Whenever you solve multiplication, check it finally. Is it of the order of 1 by 2 or whatever are the leftover numbers? 1 by 2, yes, it is 1 by 2. So even before starting the multiplication, you should know the order of the matrix. This is the number one technique to avoid silly mistakes while multiplying. A step-by-step guide of multiplication has also been given in the textbook. You may refer it in the future if you want some revision on paper. So here it's 2 by 2 into 2 by 2. That means the answer will also be 2 by 2. So this into this gives you the first element, which is 15. Then first row into second column gives you the second element, which is 22. Then second row into first column gives you the third element, and the second row into second column gives you the fourth element. So the formula is this. This is what you have to remember. Now if you forget it and accidentally do something else like first row into second column or second row into first column, you'll get it wrong. So this will require a lot of practice, and then it will become very easy. So have patience and perseverance. Let's do one more sum, the fourth one. So two matrices are given and we've been asked to multiply if possible. First check the order. This is 2 by 2 and this is 1 by 2. We always check the number of columns here, number of columns, okay? And here we check the number of rows. Clearly they are not the same. That means multiplication isn't possible. They are not compatible. That's a rule in matrices. So multiplication not possible as they aren't compatible. Next, let's do 2.2. A and B have been given. First of all, we have to find BA. Remember, BA is not the same as AB in matrices. So B is 2 by 2 and A is also 2 by 2. Great. So are they compatible? Yes, they are. And before solving, just imagine how many elements will be there in your final answer. The order of the final answer will be the remaining numbers, which is 2 by 2. So the final answer should be 2 by 2. That means there should be 4 elements. Always start a sum like this. At least get the skeleton crystal clear in your head that your final answer will have 4 elements or 2 elements or whatever number of elements there might be. This way you will never make a mistake. And in our syllabus we don't have 3 by 2 or 2 by 3, fortunately, which would have been more complex. Maximum we have 2 by 2 into 2 by 2. So the formula, if you want, initially you can write the formula in pencil because you are not yet an expert in this. It is always first row into first column, first row into second column, second row into first column, and second row into second column. Now whatever was in blue is from the first matrix and whatever is in black is in the second matrix. Remember that. So the first element is first row into first column. First row into first column. That is 1 into 0 minus 1 into 5. That is 0 minus 5. 0 minus 5. Some silly mistakes I've seen is like 1 into 0 and again 1 into 5. No. It's 1 into 0 and minus 1 into 5 and then add them. That is 0 minus 5 is minus 5. So first element is minus 5. Now next element, first row and second column. First row, second column. Okay. So 1 into 2 and minus 1 into minus 2. 1 into 2 is 2. And minus 1 into minus 2 is also 2. So 2 plus 2 is 4. That's your second element. Good job so far. Now, second row into first column. That's your third element. Second row into first column. Second row is this one. and first column is this one. Okay, so you can circle it if you want to. 3 into 0 plus 2 into 5. That's 3 into 0 is 0 and 2 into 5 is 10. So 0 plus 10, answer is 10, third element. So far so good. And finally the fourth element, it's second row into second column. Second row, of course, and second column. Notice that the location of this element is also second row and second column. So this is not just the formula of how to calculate, but this is also the location of an element. That is the biggest trick to remember the formula. If you ask me what is the formula for the third element, just tell me the location of the third element. The location of the third element is the second row and the first column. So now I will go back to the question. Second row means this one and first column is this one. Of course, they have to be from two different matrices, okay, not from the same matrix. So that's how you can remember these formulae, and you don't have to write them in every sum. So second row into second column, that will be 3 into 2, 6, and 2 into minus 2 is minus 4. So we add them and we get 2, and this is your final answer of multiplication. So it's just 3 steps, but it took a lot of time to think. That's because it's an initial stage. So invest time while doing the sums, even the done sums. Don't just copy. Try to do it on your own and then check, are you getting it? Are you getting the hang of it? And then do the remaining sums and check the answers. And believe me, by the time you are done with this exercise and the SEs, you will be the master of multiplication of matrices. Now Roman number 4 is IB. If you remember, I is an identity matrix, and in the question they have mentioned it's order 2 by 2. Obviously, then only they could be multiplied. Now the property of an identity matrix is when you multiply any matrix with it, you will get the same answer. So I'm writing the same B matrix again out here. But what I would like you to do is actually multiply it by this method and check, are you indeed getting the same answer by multiplying it? Then only you will have an intuitive understanding of multiplication and what is so special about identity matrix. So do it. Next, sixth one, B squared A. Well, first I'm going to do B squared step by step, please. So B into B, 2 by 2 into 2 by 2, so the answer will also be 2 by 2. This element is first row into first column. This element is first row into second column. This element is second row into first column, and this element is second row into second column. And then you add, subtract, and you get 4 elements in the matrix. That's the answer for B squared. So again, do not just copy, do it on your own. Pause the video and try it on your own and check if I'm getting the right answer. If it's wrong, cancel and redo. Only by making mistakes and learning from them will this concept be crystal clear. There is no other method to master this exercise but to practice. So once we've got B square, now let's do B square into A. So B square is a single matrix and A is this another matrix. Here the order matters, of course. So 2 by 2 into 2 by 2. So again same thing. Again 4 elements. You know how to multiply. Solve it on your own. Check, are you getting this answer? Signs matter. That's a second biggest silly mistake I notice. Signs are wrong. And I would like to hear how many errors you made and what errors did you make. You can message in the comment or tell me during the lecture. How was your learning experience in this exercise? Cancel question number 3. Let's do 4.2. Now here they have given that this into this is equal to this matrix, and we have to find the values of x and y. So since it's already given as equal, we can write the equation. There is no LHS RHS here. There is no proving sum here. First element is first row into first column, which is x plus 0. Similarly, second element is first row into first column, which is x into 1 plus 0 into y. That is first row into second column. And the third element is second row into first column, and the fourth element is the second row into second column. And now these two matrices are equal, so we can just equalize the elements here. So x will be equal to 2, x is equal to 2 obviously, minus 3 is equal to minus 3, sure, and minus 3 plus y is equal to minus 2. So using the comparison we can find the values of x and y. Next, let's do the fifth sum. So 3 matrices are given, A, B and C. First we have to find AB and then multiply that with C. And in Roman number 2 we have to first multiply BC and multiply that with A. Will they be equal? Yes, they will be equal because the order is same, A, B, C, A, B, C. If the order would have been changed, then the answer would not have been the same. So first, let's do Roman number 1. First multiply AB, get this answer. Then this answer is multiplied by C. Remember, C is on the right, so write C on the right of this matrix of AB. And then you get these answers. So again, do not copy, solve on your own, pause the video, check are you getting this answer. Next, Roman number 2. First we'll multiply B and C, we'll get the answer. And now we will multiply A with that answer. And remember, A is on the left, it comes first. The order matters here. So A into BC, BC we found the answer. So again multiply and check are you getting this answer. And then we will say that indeed they are equal. Cancel the 7th sum, let's do the 8th sum. Show that means we have to prove that m square is equal to 2m plus 3i. I is the identity matrix, of course. So we will do LHS RHS here. LHS is m squared, that is m into m. Do the multiplication, get this answer. And the RHS, 2m plus 3i. So 2 into m plus 3 into identity matrix. 2 by 2 is always the diagonal is 1 and all the other elements are 0. This is multiplication by scalar, which we have done, which is so easy. Multiply 2 by each of the elements, and here multiply 3 with each of the elements, so it is getting absorbed by the matrices. And then addition also we know, add the corresponding elements and we get the final answer. And check, is it same? Yes it is. So we say that LHS is equal to RHS for this sum. But is this a universal formula for matrices? Try one experiment. Choose some different values of M matrix and then do the whole sum in rough work and see, is it still true that no matter what elements are there in M, this equation is always true? Is it? That will be a very interesting discovery if it is universally true, this formula. Like in algebra we have a formula, a plus b the whole square is a square plus b square plus 2ab. But those formula are not applicable for matrices at all. But do matrices have their own unique formulae? We'll have to find that out through trial and error. 10th sum, cancel it. Let's do the 12th sum. Find the matrix A, and this is given. So this is given, we don't have to prove it, but we have to find the matrix A. So I want A alone. First of all, substitute the value of B matrix. Square is there, so write it twice, is equal to B plus half A. This is a multiplication, so 2 by 2 and 2 by 2 will give you 2 by 2 answer. do the multiplication, don't copy. This will go to the LHS and will become subtraction as usual, and half A remains here. We know how to subtract it. Subtract the individual elements, corresponding elements, and get a single matrix. Half, well, it will go up and become twice. So now I have A alone, which is twice of this. The 2 gets absorbed, and this is the final answer of A. Next, let's do 14.1. Show that. That means you have to prove that distributive multiplication is allowed in matrices, is it? Let's prove it. So we start with LHS. Now you could have done B plus C first and got an answer and then multiplied by A. I'm doing it all together. A, substitute, brackets are there, so please add first, bottom-us, B plus C, we get a single matrix, and then do the multiplication, we get this for the LHS. And for the RHS, it's AB plus AC, so A into B plus A into C. You all know how to multiply. Now pause the video and do it on your own. Did you get this? Or did you make some mistake? So I got 2 matrices, add them and you get this answer, and which is the same as the LHS. So LHS is equal to RHS. Cancel the 15 sum. Cancel 16.3 as well. Let's do 16.2. Solve for x and y. First of all, are they compatible? Surely they have to be. This is a 1 by 2 matrix, 1 by 2. There are only 2 elements here, remember. And this is a 2 by 2 matrix. So number of columns and number of rows are matching. And the answer should be 1 by 2. Yes, answer is 1 by 2. Correct. So I'll multiply the LHS. Let's see how it goes. The answer will be 1 by 2. So I need 2 elements. In the final answer, there should be only 2 elements. Here it is first row into first column. This is first row into first column. X plus y into minus 1 plus x minus 4 into 2. That is entirely the first element. Okay, don't think of them as separate elements here. Next, what's the second element? First row into second column. That is x plus y into minus 2 plus x minus 4 into 2. That's your entirely the second element. Solve them further. So you reach this step. So this first element is equal to this first element, and this second element is equal to this second element, because they are equal matrices. So we get 2 equations, get the value of y and get the substitute that and get the value of x as well. Next, let's do 17.2. Now that is a super IMP sum. It's amazing sum. Here we have to find m. First of all, here the order was 2 by 2 and the order of the answer is 2 by 1. So we have to find out what should be the order of m. That's the first step, and that is question number A, order of the matrix. Well, it has to be 2 by 1. How do I know that? See, only if the number of columns and number of rows were equal could they have been compatible for multiplication. So definitely the number of rows of m has to be 2. Secondly, the remaining numbers should give me the order of the answer. So here 2 and 2 matches. So here this has to be 1 because here it is 1. So remember, this one will be same as this number and this one will be same as this number. This is always the case. So you have to think logically like this, because only once we know is it 2 by 1 or 1 by 2 or 2 by 2. There are only 3 options in our syllabus. We can have 2 by 1, 1 by 2 or 2 by 2. That's it. So the order is 2 by 1. 2 by 1 means 2 rows and 1 column. This is 2 by 1. So let the elements be x and y. And only now we can solve. So copy the question, but instead of M matrix, write x and y. 2 by 1 order. Even if they would not have asked the A part, to solve the B part, we would want to know the order of m. Now how to solve? Well, the answer should be 2 by 1. That means there should be 2 rows and 1 column. 2 rows and 1 column. That means 2 elements only. There should be 2 elements only. Isn't it? The answer is 2 by 1. The answer is indeed 2 by 1. They've already given the answer. Alright. First element. First row into first column. 1 into x plus 4 into y. 1x plus 4y. That's a single element. Second element. Second row into first column. There is only one column. So 2x plus 1y. 2x plus 1y. And now equalize the matrices. So we get two equations. Solve simultaneously. Get rid of x or y, whatever you want to. Get the value of y. Substitute and get the value of x. Next, cancel 18, 19, 20. Let's go for sum number 22. 0.1. We have to find p square minus q square. Then we'll find p plus q, p minus q. And then we have to say if they are equal or not. And I guess they will not be equal, because even though it is a formula in algebra, such formulae are not applicable in matrices. So let's give experimental evidence here. P squared, you could have solved p squared separately and q squared separately and then subtracted it. I'm doing all together. P into p minus q into q. P into p multiplication gives this answer. Q into q multiplication gives this answer. You multiply on your own, and then subtraction gives us this answer. Fine. Next, p plus q and p minus q. You will notice many cancellations, because when we solve in a hurry, we make silly mistakes. So I expect you all to have cancellations in your book. If you don't, that means either you are a super genius or you have just copied. That doesn't mean you give some fake cancellations in your picks. P plus q and p minus q. So p plus q addition we know how to do. P minus q is so easy to subtract. But then we have to multiply these two matrices. 2 by 2 and 2 by 2. So the answer will also be 2 by 2. So are the values same? No, they are not. So they are not equal. Next, cancel question 24, 27, 28. And even 31. Cancel them. Let's do 26th sum. In sum number 26, they have given a minus 2i. I'll find that first. Then I'll find a minus 3i. And then I will multiply them. That will be easier. So a value is given. Identity matrix is always this fixed. So 2 is absorbed here. Do the subtraction. Get the answer. Similarly, a minus 3i, 3 is absorbed here, subtraction, get the answer. And these two matrices now multiply. We know how to do that, and we got this as the answer. Sum is over. So I hope that now, as you reach the end of this exercise, you are quite comfortable with multiplication and are confident about it. Now the 29th sum. It's given that the product of p into q is a null matrix. Null matrix means that each element is 0. Well, since it's 2 by 2 and 2 by 2 and the multiplication should also be 2 by 2, so we'll also take null matrix as 2 by 2. So there are 4 elements. Null matrix doesn't mean it's an empty matrix. It's not empty. It's filled with 4 elements. 0 is also an element. So let's multiply. First row into first column here. Second element is first row into second column. Third element is second row into first column. Fourth element is second row into second column. What, you've forgotten how to do it? Come on, revise and do it on your own. So I got 4 elements here. So this is equal to 0, this is equal to 0, this is equal to 0, this is equal to 0 on comparing. Take any two of them. I'm taking this one and this one. This will give me the value of y. This will give me the value of x. And the sum is over. Finally, the 30th sum. Now here you'll need knowledge of the values of the standard angles, trigonometry ratios from the 9th standard table. Remember? And such sums are my favorite. So you should revise all the values. There is a trick to remember all the values of the table, but that's time consuming. So it's better to just memorize all the values of sine, cos, tan, cosec, sec and cot of 0, 30, 45, 60 and 90, because such sums will come in exam for sure, at least one such sum. So pause the video and revise that first. In the D exercise you have many sums like this, and I don't want you to just copy from here. So you should know that cos 60 is half and sine 30 is also half, and that tan 45 is 1 and that cos 0 is also 1, and you should know the value of cot 45 and sec 60 and cosec 30 and sine 90. Do you know this? Can you just close your eyes and tell me the values of all these trigonometrical standard ratios? If not, then go and revise from the 9th textbook. You can even Google the table and learn it by heart. Write it 5 times if required. So this sum will become easy once you know the values. Just substitute the values, 2 into that value, minus 1 into that value. So you get 2 matrices. You know how to do multiplication, and this is your final answer. That's it. Hi students. If you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.